So I didn't start with solar physics and mine. That is for sure. I didn't say that I have to do solar physics or I have to do computational physics or something like that. A little bit of coding, a little bit of curiosity has shaped my whole career right now. Not whole career, half of my career so far. And third thing is you don't need to know your final destination from day one. So like wherever you start, just start. You don't need to know where you have to go because there are no limits. You can change your career. There are interdisciplinary things like I am giving talk here as I am from physics major. Still I am giving talk here. So coding and knowing programming these days is one of the fancy things, and it can be used in many different ways. One of them is in physics, and that I will tell you. So all this starts from RRCAT, Raja Ramana Center for Advanced Technology. That was my I was brought up there. My birthplace was BARC Mumbai. So I got exposure to science here only. Like my surrounding was full of scientists and research going on inside RRCAT. And I got to know about IISER also from here itself. My seniors, like some of my seniors were in IISER Bhopal or Pune. So at that time when I joined, people were not like that much interested in research or something, I think. Because around me it was a bio bubble. People knew what is IISER, but outside they doesn't know what is IISER. So my parents knew and they wanted me to get into the IISER. So when I applied, I didn't study that much. Okay, let me be honest. I was not a very great student. I was very average student, or little bit above average, and I was more into sports or co-curricular activities. So when I applied for IISER, I was not that sure that I will get it. But luckily, I got into ICTVM, and it was Corona time, COVID time. So first year was fully online. It was a new start, but there was nothing to start. Everything was online, and I remember first month, I guess, first 10, 15 days, I was very nervous about classes. Everything was going on. I didn't do anything much. Uh, First year, our classes started. We got to know each other. Many friends were there. Our classes were fully, the curriculum was set. We were told that you study this. After seeing curriculum, I can't see myself anywhere in 5 years. I have seen 23, 24 batch. I have met them and they're like, oh, I want to go into a SO and this. I didn't had that kind of vision. I was very confused. Then first year went into the online mode. End of the second semester, we came to the campus and gave our exams, final exams. So now everyone started talking what will be major. So I was clear that I can't do chemistry and bio. It was not my thing. I have good grades in that, but I can't do that. So I had this confusion between data science and physics. Data science because I had in my plus two I learned C, C++. So I had some skills in that. So I thought of giving a try to data science, but I was not so secure. I wanted to keep something safe for me. So physics was one of the things for me, and I was very curious about this astrophysics and all. Everyone have these curiosities, what's going on in the space, what's happening around the earth and all. So I took that chance and got into the physics. But like after deciding physics, but before that also many questions came. What will I do after this? People asked me, my family asked me. So I was not so sure about it. Some people might be feeling that thing right now. So I'm clearing that everyone have like clear path or something like that. You don't need to worry about those things. Eventually things happen and you will get to know where you will end up. So yeah, after that life got more serious. Then I went home. I utilized my 3 months of break with the NPTEL courses. I did some courses and some coding to enhance my skills. Then third year came. In third year, I was physics major and mathematics minor. I got physics major, but it was not so easy to deal with physics major because one of the top minds in the campus are competing with you there, and you have a later grading for sure. Then some of the courses we had, like quantum mechanics, very core courses were there, and I explored many of the different fields of physics. I knew things are not what we see from outside. Like now, pre-majors are there, you can see, but at our time it was not like that. So we got to know about different core courses. Then I liked theoretical physics a lot at that time. Then after, like I didn't even realize in third year was already gone. Everyone started finding internships and all. I applied for internships. The only one thing works is cold emailing. I did a lot of cold emailing to different IITs, different research organizations, and TIFRs and all, but you don't get that much replies. I mailed like professor several times, and still I had no replies. Like I somehow at the end of April or something, I had two positions. One was in IIT Kharagpur and one was in IIT Guwahati. So I had to choose one. In IIT Guwahati, it was about statistical mechanics. I just did that course, and I wasn't that much sure that do I need to explore this. I applied. Yeah, this is all one of the things that I wanted to explore different fields. I have done the courses. I know these things, but I'm not sure what I should proceed with for the research experience, because this will add into my CV, and I have to uh, work after going there. So if I don't like that thing, you don't know how to proceed with that during those 2 3 months. So, but I also had this BARC thing. BARC thing was came from coming from my parents that you should apply for back internship also. So I applied there and luckily I got it. Like they sent me the mail that you are selected and you can apply for it. It was a government organization. It's a very prestigious organization in India. So that was a yes that I went for it. And after going there, my experience in BARC was quite like different from what I expected. It's a government organization. You have no guidance from the supervisor. There are no PhDs to help you. There are no TAs to help you, or you are you have to do independent research. There is no one to exactly like guide you how to proceed with every step. What we usually have in different institutes or IITs or IISERs. There will be some PhDs in the lab or some senior student, master students, but no one was there. When I started my project, which was titled like magnetic field calculation for magnetic optical trap and study of upconversion nanoparticle, it was done under the guidance of Dr. Govindan Sridhar, who was a scientific officer there in Advanced Tunable Laser Applied Division, which was BTDG group. So in this, what I did was I developed some mathematical models to calculate the magnetic field of magnetic optical trap, in which atom can be trapped inside it. Like that is called the cooling of the atom using the lasers. So to study a particular atom of any molecular compound, like you can study the atom by using the lasers also. I got to know these new things after going there only, and these can be used in biomedical things like different medical fields and the literature study, what I did there was subconversion nanoparticle, which I didn't knew. What was that? Because I was nowhere near nanoparticles and all. So after going there, I explored different fields. And BARC actually, it's not like if you're a physics student or a physics major from MSc also, when someone joins there, it's not just about physics. If you are a physics major, you should know chemistry, bio, mathematics, or programming, because everything is interdisciplinary there. As the BARC title shows you, atoms in the service of nation. That is what it is in BARC. So BARC is one of the organizations which is working for the people. So if you're planning to join there, I would like to suggest you should have enough knowledge what you're going for. And second thing, you should know how to do independent research. So those things should be very clear for you. It is a very prestigious place, so I will suggest you guys like once in whole your career you should go and visit those places, because the security and it's very confidential research area. So I think you should try once. For the fourth year, when I came back to the campus, and in fourth year you have more leniency in choosing your electives. So going to do, I knew that I like computational physics and I like astrophysics. So I was planning to do something both. Like I will combine both. I didn't even knew that that can be possible. So I searched some of the fields which can be relatable to these two fields. And the electives chosen by me were like solar physics, atmospheric physics, astrophysics, and statistical and data analysis in the physical sciences. These four courses made me realize that I like these things. I like I like in solar physics. I didn't knew that okay, there's a study on sun also, and sun have its own dynamic processes which are going on inside it, and we can study those things using the data of different satellites. And that's why after that year ended, I applied for one of the internships in IITs because already one of the government organizations was done, the ARC. So now I wanted to do something. I want to explore where someone can guide me. So I applied in IITs. So this time I got one position in IIT Roorkee. Uh, Summer 2024, I was an IIT Roorkee. That was a very nice experience for me. I really liked working there. IIT Roorkee is a very nice place. Quite it was hot, but it was really nice, and the work culture is really nice there. So, in in IIT Roorkee, the internship was about, my research was about analysis of temperature and nitric oxide variation in the mesosphere using SOFI observation. SOFI is one of the instruments which is boarded on a aeronomy of ice in the mesosphere spacecraft of NASA. So the data which was available online or NASA's website of SOFI that was used for the analysis of nitric oxide and a temperature variation in the atmospheric layers of the Earth. So I analyzed that data for some of the period of the time that was 2017 or 2018, and that we can see that like how much variation can be seen over the years and how it is changing over the time, and that is used for the further studies which were used by some project there. So I was a part of a project. So I did the guidance was really good, and IIT Roorkee is one of the really nice institutions for physics, I guess. So my advice will be IIT Roorkee. You guys should try it. Like every IIT have its own like very nice physics department. The research is really good. So for atmospheric physics, this professor, Dr. M. B. Krishna, actually I found because I did an NPTEL course last year, 1 year before this, and I did his course for that. So I applied under him, and luckily he got me. He took me, and so like I got the opportunity to work under him. So I think you guys can apply the field you know already know, or like the place you have already explored for, or some field you are just some spark is there, like you are interested. Okay, I want to try this. So internships are made for that only. So I think internships shape your career a lot. I learned a lot of things like. Uh, Using Python was like I have never at that time, like 5 years ago, I never thought that I will use Python till the last, and I was not that much amused by data science or something. But gradually, when I got to know that yeah, physics is too much dependent on data science, so I really like I really started liking it. So after IIT Roorkee, this is one of the animations I used for my presentation before also like this is the aircraft. Different molecules which can be used for the analysis. That's nothing much fancy. So finding the pattern, data is everywhere. Yeah, this is true. The people who say that astrophysics they want to do and they want to work under, like in our institute, there are not much people, or like there are not much professors who are working in these fields, because I got to know because Dr. Nitin Yadav was here. Dr. Nitin Yadav is not anymore here. She left the institute, and now there is no one. Like only Shabnam is left, I guess. So I really feel bad for the people who are not able to like explore these courses, because getting to do electives is very important. From electives only you will get to know what is happening, and in a particular field what is important also, what you should know, and for in that field only you can apply for the internships. So the common thread was data is everywhere, and I learned from these internships. I learned like how to use Python in physics, and what problems can be solved, how we can analyze the satellite data for our use, and the libraries I work in all were useful at the end. So in fifth year, when I applied for Dr. Nitin Yadav's lab, I wasn't for sure like she will take it because she will take me because a lot of people were there who wanted to do astrophysics. As in your batch also, you can see many people are there who want to do astrophysics and they're very fascinated by astrophysics. So I think what you guys think in first and second year, what is astrophysics, is quite different from what you get to learn. Like the people who already know the well and good. The people who doesn't know, they have just seen some pictures and they're like, okay, this is good, astrophysics and this is good. So I think for that, you should know what is actually going on in particular subject or particular field. So for that, internships are. You should go, you should try, you should explore the fields. You don't like it, it's fine, but at least you should have some experience in that. So you shouldn't worry about grades or like whether that person will take you, the organization is very big. Just apply. You don't have to think that much for these things. So in fifth year, I started working in SOS lab, and the project I did there was an exploring acoustic wave power as a plausible source of hot coronal loops under Dr. Nitin Yadav. So this project was about coronal loops which are formed on the sun. As you can see in the animation, there are some loops which can be seen. Those are the coronal loops. So I will tell about that now. And the satellites data which was used was IRIS and STU, interface region, imaging spectrograph, and solar dynamics observatory. These two instruments were the NASA's. These two spacecraft are the NASA's spacecraft, and the data recorded by both of these are publicly available for all the people. So these data, I use these data for analyzing slow magnetoacoustic waves, which are of time period of 3 minute and 5 minute minute period bands. So the sun can be seen in different wavelengths, like 171 Armstrong, 304 Armstrong, 1700 Armstrong, and every instrument sees the sun in a very different way. So every different frame shows you a very different um, properties or different dynamic processes going on inside the sun or on the sun. The uh, actually why we are studying sun. Sun is one of the stars, but that doesn't act like the other planet or stars do. As we go away from the Earth's surface, the temperature decreases. Or if you check any other planet or star, we usually think that if you go away from the surface, the temperature should decrease. But for the sun, it is not like that. For the sun, it is quite opposite. Like if you go away from the sun, for some time it will decrease, but exponentially there will be increase in the coronal layer. That is called the corona layer, outermost of layer of the sun, which is the sun's atmosphere. So that have like extremely high temperature or like approximately 1 million Kelvin. So this layer have different phenomena, and this whole thing like heating of the outermost layer of the sun is called coronal heating problem, which is the major problem in solar physics. So the arc-like structures which are on, which are seen on the sun, which are the coronal loops, which are studied for knowing how this layer is so much hot and how the temperature is increasing exponentially compared to the surface. So these loops are considered as the source of the waves, and the waves are of different time periods. So as they come from the surface of the sun to outward the corona part, the period of the time period of the waves decreases, and how they converts this wave mechanical energy. That is what I was studying there in this project, like how these waves are responsible for the coronal heating. In this animation, you can see the flaring loops, and on the right hand side up you can see the umbra, penumbra, and this is the sunspot basically. The black part is umbra, and then orange part is penumbra, and rest is the white sun, which is having granules, and which is like boiling milk, which comes up as plasma in sun. Like it comes up and then cools down and goes back. But in loops, it is quite different. Like in loops, which are coming in inside from inside the sun, and they're coming to the surface, making the arc like structures and going back. they have the unipolarity at different hemispheres. Like we have a cycle, sun also has a cycle of like 11 years. So these were the things which I got to know after studying solar physics. Maybe you guys might have seen somewhere or like studied these things, but after doing solar physics, I got to know about most of the things in detail about sun. Then the analysis how I did with data science in this, like by programming and all, using Python. I have only used Python for this. For simulation part in solar physics or astrophysics, you can use different codes which are like neural codes, which are already there in like Fortran language or different languages which are used, which are ancient languages. These days we are using mostly C++ or Python. So first I downloaded these Flux file, then I have extracted the light curves from the intensity maps, then I have applied fast Fourier transform or wavelet analysis, which are one of the methods which are used for wavelet for the analysis of sun surface and intensity analysis. Then I have interpreted the physics behind it. So for just knowing the data science or just knowing the physics is not one of the things which will solve some physics problem. So for doing this project, I had to have one of the prior knowledge of solar physics and the data science knowledge. Then only you can get to know what is exactly going on the sun. That's what I learned from SOS lab. The environment here was really nice. Okay, so some of the people were worried about going outside for their major projects. For me, one of the reasons for staying inside, like on the campus, for my major project was to spend the last year of my 5 years of degree on the campus with my friends. And as what I was interested in, I already got here, like Dr. Nitin Yadav. As she has left, people who are interested in solar physics, they have to apply outside, or people interested in astrophysics have to apply outside this year because there are no professors for that. So I will stay if you have your field on the campus. Just take it like you can do PhDs outside or like you can do some internships outside. But major project, if you do it here, that's a good thing. It's my opinion. It's not mandatory for everyone. So for I thought in this way, and I continued my project for 1 year long period. So that was my 5 year journey till now. I applied for PhD. Okay, so in August, in fifth year, the people who are entering fifth year, you have to worry about your career, like what you will do next year. At this time, in August, what you will be doing next year. People start thinking like that. So everyone will hurry and they will prepare their CV, SOP, motivation letters. There will be some positions in US. They will give TOEFL, IELTS, or whatever is needed for your application process. So what I did, one of the seniors who has joined for this talk also, I literally troubled my seniors a lot. I asked a lot of questions. I was very curious how to apply for internships, what to do, how should I proceed, and these things were new to everyone actually. So I think your seniors are the only one answer for this question. Like, if you are, if there is a silly doubt, also you can ask to your senior because your supervisor you can't ask. Your PhD guide maybe you can't ask because they are also busy with their own work, or you don't have that relation of finding solutions to silly questions. So I pestered my seniors a lot for this. That please tell me what should I do, how should I apply, because I was very scared what will happen if I don't do this. So these things, I'm not saying that you should be scared, but yeah, you should have some kind of clue that what is happening. If you don't have, ask around. There are lots of people who will help you for these things. So I did that, and I got somehow grabbed a position in Charles University. But from August to December, I kept on applying. I couldn't make for one single interview. In January, I filled for Charles University and many other universities like Warwick, University of Sheffield, in Europe only. I had this thing like I have to go Europe only. So I applied for many European universities, good universities, and I took a lot of advices from seniors, applied to this university, that university, do cold emailing. Cold emailing works a lot. Still, I have not done that much cold emailing, but my friends has done a lot, and they're giving a lot of interviews. So I think cold emailing works in internships, PhD, masters, whatever you want to apply. So this is one of the key to if you are not eligible for some application process, still this will work. Coding mailing, you never know where the opportunity is available, and you mail someone and somehow you got that opportunity. So these things were one of the key points for for everyone sit this there. So Charles University, my project will be about what I have done till now, solar dynamic processes, what I learned, and extra is solar wind, which is coming from the sun, as you can see in the animation. The solar wind coming from the sun to the whole space, like to the sun, from the sun, the solar wind which is coming to the earth. We have a Earth's magnetosphere, which is a shield for Earth that is that have its own bow shock and magnetosphere's tail, then it have its own magnetosheath. These things are components of magnetosphere only. So when solar wind comes from the sun, it interacts with our Earth's magnetosphere. So that is where I will study I will apply the data science once again, the key for this, and some machine learning techniques for my further explosive CME or white CIR events which are going on in the space. And this is a 4-year PhD. I got this offer in March, and I will be joining in October starting week or something. So this was about my PhD project. So what this journey taught me, this 5 years journey till now has taught me that you should follow the spark, not the map. There is no particular map. Everyone is unique. Everyone have their own talent or unique interests. So you never know what make you excited and what is more fascinating for you might not be for anyone else. So these things are there, and then programming didn't just solve equations. Yeah, because I used to think like before second year something only equations or some data management thing or something can be done from the programming, but I realized soon in astrophysics that it reveals the patterns in nature, and you can see things with a different angle, and you can see many different processes going around you. And yeah, third thing is you should ask questions. Questions, maybe you might fear not to the supervisor, not someone who can scold you. Just ask around your people who are there. Maybe they might know something about the question you are having, or something might get clear up in your mind from anyone's opinion. But yeah, cross verify it. Like you have to do that again and again. But yeah, ask questions and embrace your uncertainty. If there is no plan, wait. You can't, I'm not saying just wait for it or like, but yeah, things work out in the end. Start wherever you are, just start. Don't care about your marks or wherever you don't have any prior research experience or anything like that, because these days people are doing internship in second year also, but we didn't do that. We had COVID and we couldn't do that. So in third year also we got internship. So don't think who will give us internship or how we will get it. Just apply. If you have a position, apply for it. You found some professor, just cold mail them. You will get some good position, or you never know what is waiting for you outside there. So yeah, that is one of the lessons I have learned. And your path doesn't have to look like anyone else. If someone is getting something, it doesn't have to look like their journey or their path, what they did in their life, because everyone have their own life and own unique interests. So yeah, that is one of the things I learned from this whole 5 years. So these are some people who I am very glad that I met very nice friends here, and those people helped me a lot throughout this journey. I played a lot of sports here. I utilized all the facilities which IISER gave me, other than the Miss Food part. So it was a nice journey, and I hope this talk might have helped you a lot. And in some way, you might find this helpful, and you can contact me anytime. This is my mail ID. So thanks for traveling with me, and stay curious. the universe rewards it. So believe in yourself. That's it. Thank you so much.
Thank you so much for amazing talk. If anybody has any questions, they can, raise their hand on the camera and talk, or they can just, send it in the chats. Yeah, go ahead.
Very well done presentation, Pragya. I think your camera is stuck. I cannot see you. Yeah. Okay. So I'll ask it
Can
later.
you
I
see me?
forgot.
Are you talking about me? Oh my God.
No, Pragya will not know.
Hello.
Shit, yeah.
I think we have a
Okay.
question from Rahul. He was raising his hand.
Okay.
Rahul, do you like to answer? Okay. So I had a question, Pragyati. You
Yeah.
talked about applying to BARC, and you
Yeah.
talked about applying to government institutions. So, like, what is generally the process about it? Like not
So
academic institutions, industrial oriented government institutions.
So, if I tell about the government organization in India, so the thing is, they're very old fashioned. Because what I went through in Park is like you have to apply, like there will be some stamp and seals, a lot of formalities. You have to be there 1 week before for your ID cards because it's a very confidential place to enter in. So like you can't take your mobile phones. None of the electronic devices are allowed there. So like getting into these things, some of the ISRO, DRDO, or BAR, these things have their own websites, and some of them have their own helpline numbers, or some of them have their own scientist details, which is not very common. So for BARC, for me, it was like I have to send my some of the official documents and which are needed. There is BARC Students Corner for BARC. So you have to go on that. Some of the things are asked there that you have to provide this and that, and some of the bona fide or kind of thing, which you usually give for your internships. These things you should post them. There is no online thing for BARC. You should post them in hand. So like you will do some speed post. They will receive it by 1 week or something. Then there will be one website of them. It is very old fashioned. So you have to be very patient for that. So like they have their own website. They will update there that okay, this is in process. This is in technical screening, and this one is the one which is rejected. So there will be name, institution, everything. So that was the process for me, and I think I had 2, 3 people more to apply there. So this is the process what BARC have for DRDO and ISRO. You have to apply online only. I guess they have their some deadline kind of thing if you want to apply.
I have a question related to that. So you said when you worked there, like you didn't have any PhDs or you didn't have anybody advising you. So how was
Uh,
that like compared to
Actually,
working behind?
it was quite depressing to be honest. That was my first internship. I was there after third year. So if we are here in third year and we think, okay, we don't know much about it because we have 2 more years to explore, but they expect in BARC or some good prestigious institution, they expect a lot from you. That you should know how to do independent research, that you should know how to manage your own research things and all. So for me, it was quite depressing because no one was there for help. You can't seek for any help. If you ask, also they will scold you or something will happen like that because they are also pressurized by the superiors there. So I found it. I shouldn't say that, but I found it a little bit toxic to work there. For me, it was like that. It may be different for someone else. For me to work in a laser department, it was quite depressing. But yeah, if you know how to work independently, I was quite young for that maybe. So at that time, I had this problem. But it was quite good. I learned a lot of things. But yeah, it was depressing.
Okay, so now Vaibhava has a question, so he can turn on his mic and ask.
Yeah, I just wanted to know what in particular in data science, like, is there any Python libraries which we need to learn so that, even I send code mates, but they see my resume and there's nothing more in that. So can you help me with anything which I could put in my resume?
Can I know like which field you're from, like which you're from data science particularly, or you're from physics or any other?
I'm from physics and I was trying in a few institutes of astrophysics.
Okay. So first thing is just let them know that you have done several, like we have some foundation courses of Python or C, C++. Just mention that. And if you don't have a prior, like if you don't have some experience before, if you're doing your first applying for first internship, I will say just fill the CV with some of the things you have already attended, some workshop you attended, some course you have done, NPTEL course or something. So there are some these days some programming courses also, or something you have learned, something which can highlight your CV and make it different from others. Just include something like that. And sometimes if you include your co-curricular activities also, that can also help. But for physics, what helped me was including some workshops and some of the courses, and elaborating my skills, like what libraries I mentioned were SunPy, Astropy, NumPy, SciPy, and I have dealt with .NET CDF files, .fits file, or you have to tell them that what you have done properly. I hope that helped.
And also, we don't have any astrophysics faculty after anything within MAM left. So
I know, right? This is a very great loss to ICT. Let me tell you, like this year, the people who wanted to do their physics major in astrophysics, and they have to apply outside, but sometimes they're not getting their like permission for that, or CAD will do something that okay, you can't go outside. So these things are a problem. I think you can write to academic office or your HOD that there are no faculties, how you will proceed in astrophysics as a career option, because these things are really concerning for ICT, because this department now doesn't have anyone who can support in astrophysics.
thank you. And
Okay.
also, we'll miss Bob Baya from next year.
Okay, so Pragya, is it possible like use satellite image to find water in Rajasthan?
I
You didn't get it? Like, is it
I can't
possible
hear
to?
you properly, Bob.
Oh shit! Maybe I'll type the question.
Can you repeat?
I'll type the question for you, and maybe it will be better.
Yeah. Please.
We have two other questions like in
Okay.
chat. I'll read it out. Or can you see it?
Yeah.
Okay. I'll read it out. So Rahul has asked, what will you say is an essential research skill that you learn
I
from
will
your
read.
past?
But it's fine. Pragya Didi, can you tell us about the quotes? Hello. I think my network is not good. Hello.
Yeah, we can hear you. Yeah.
Hello. My network is not. Yeah, can you repeat the question? I'm so sorry.
Yeah, so Rahul has asked, what will you say is an essential research skill that you learned from your past internship?
Um, Skills. I think mm, getting to like skill as in, I will say, grabbing things very easily. Research needs this thing that if something is told to you once, you should know like how to implement it, because people won't repeat it. The skill, what was useful for me was grabbing. It's like I don't really know what is the answer to this question, because um, if we combine data science and physics, like skills which are needed for my career was like I should know programming or I should have some prior experience in astrophysics or something, some course I should have done. So yeah, the skill which is needed is this only, that you should have at least some knowledge for what you're going for.
Yeah, so we have the next question from Shubham. Can you tell us about the codes you wrote for the purpose of your projects, and generally what was the level of proficiency in coding needed to be comfortable in using the applications in the interdisciplinary field?
Okay, that's a very good question. Actually, the level of proficiency is intermediate. You don't need to be a very good coder or something like that. You don't need to do. Sometimes, if you have a very good PI or something, there will be help from the PI that uh, already some codes exist. You have to understand them, and then you can use them for the analysis. And some basic analysis part, what courses are offered in our campus, like statistical and data analysis in the physical sciences, that some statistical thing you should know, and some little bit coding you should know. Like, there is no level of proficiency in programming in physics, because physics decides itself that how much you should know for a particular field. So I think proficiency you can learn every day. You can learn if you know a little bit also, like how to make loops, how to make small programs, patterns or something. You can learn. That's how I learned. You don't need to know particular like you should know machine learning or something. No, I'm still learning that. You should know a little bit of programming, and you should understand codes. If you're understanding codes, that is also fine, because these days you can make use of make use of codes, existing codes also. So in physics, there are existing codes which are already there for the analysis.
Thank you. And we have one more question. Were the internship expenses covered by the institute, or was it left to us to cover?
So no, in research, if you're in research, don't expect you will get paid for internships. This is the one of the very sad part, that we do so much work, but we don't get paid for that, and you have to pay for every internship from your pocket, accommodation and all. But when you write a mail to someone and someone replies to you, just tell them that you need some financial support. In some cases, I have seen some of the professors provide like 5,000 per month or something. They will cover either your accommodation charge or something they will provide you. So if you are in contact with some professor, just tell them that you need some financial support, or you need, will it be stipend or not, the internship will be. So it will be good. Otherwise, don't expect too much.
Yeah, Shreyansh.
So I had another question. So you worked on data from NASA's mission. You said in Roorkee. So what are the implication or application of the work you did there, like broad sense?
As I told, it was a big project, but I did a very small part of that. Something, as far as I remember, it was last year. So what I did was I was learning how to analyze the atmospheric constituents in the different layers of the Earth. So they were doing they were trying to find some patterns in all of the years, which like 2000, from 2000 to 2020, or like in this particular duration, what are the levels of nitric oxide or something which has increased or decreased for a greater, I don't know what they did after that, but that was the part that was told to me at that time.
Thank you for answering, Pragya B. Very good talk, very engaging.
I
Yes.
think there are two questions remaining.
Okay. If you want me to read them. Uh, One of the questions asked is it possible to use satellite imagery to find water in desert parts of India, like Rajasthan?
I think for that, Om Haryada should visit Rajasthan. I think there is a lot of water, and I'll make sure he doesn't feel like thirsty, like there is no water in Rajasthan. Please visit Om Haryada.
One more question from him is also, will you like to say something about your friends, the friends you made in IISER?
Okay, so this is one of the best part of IISER. Other than being depressing and these things went on, life will go on, so these things will happen. But the constant part was the people I showed in the pictures to us sitting here. Some people who have been constant for 5 years, and it have been really nice to with them. So yeah, I would like to say thank you for being there for me always. Thank you so much.
Welcome, Pragya. Welcome. It was indeed a pleasure.
Okay, wow.
Okay, so does anybody else have any other questions, or can we take like a group photo now?
Shreyansh is ready with his pose. Like, okay, let's go.
Okay, then we can take a photo now.
Yeah, everyone can turn on their camera so we can take a group photo. Yes.
I will insist, please, everyone who knows me here, please turn on their camera. Maybe this is the last meet. You all,
Yeah, Nigam.
yeah,
I
these
can turn
kids.
on the camera.
Oh, Ankit, guys, wait. Before the picture, I would like to introduce one of the legends who is present here. Ankit Yadav, he is from batch 17. He has helped me a lot with my PhD applications. So I'm really grateful he's here today. He wanted to join. So thank you so much for being here, Ankit Bhaiya.
Yeah, thank you for the nice talk, and it was really good to see you guys. I think I
Thank you
remember
so much.
most of the faces. Yeah, yeah, nice presentation. Was yeah.
Thank you. You can take a picture now.
Ashwin Nair, you're missing.
I'm here.
Yeah, I've taken pictures. We'll upload it in the drive.
Okay, thank you. Thank you, Bhaiya.
Thank you.
Thank you, Hari Yadav. Thank you, Ashwin. Thank you, Gauri. Thank you, Shreyans. Thank you, everyone who was present here today.
Yeah, thank you everyone to whoever joined, and thank you
Thank you
for your
so much,
talk.
guys. Thank you. Thank you.
Thank you, Pragya, for this wonderful talk. We hope to see you again in Coding Club.
Thank you for the opportunity, Shreyans. You gave me a very wonderful opportunity. Thank you so much.
No, the pleasure was all ours. It was very engaging and very filled with information. Yeah, so it was very amazing, especially from astrophysics, where people are very interested. So yeah, thank you for that. And I hope we see Bob Bhaiya and Bhasman Bhaiya too. I hope you'll help me convince them for the talk.
Yeah, please have a talk of both of them separately.
Yes, we'll have a good talk. Then we'll find maybe water in Uttar Pradesh. Yeah.
Sure.
Thank you,
Okay, thank
everyone.
you, guys. Thank you so much for joining. Thank you. Bye.
Yeah. Thank you, everyone, for joining this talk series. It was very wonderful to have you all with us here, and we hope to see. We have to extend this series further, and you'll see more seasons of Beyond Syntax with your favorite seniors and their valuable experiences. Yeah. Thank you, everyone, for joining.